A speeding streak of icy debris, brighter than a star, suddenly tumbling through our skies. This is no ordinary wanderer. It's 3I/Atlas, a visitor from beyond our solar neighborhood, carrying secrets that challenge everything we thought we knew about the cosmos. As it slices through darkness, leaving a fleeting trail, it sparks questions not just about its origins, but about our place in a universe teeming with unseen travelers. Watching this cosmic interloper, we're reminded how little of the universe's vast, alien landscapes we've explored, and how much knowledge, and perhaps even ethical questions, lie in understanding these interstellar visitors and what they carry with them. This journey isn't just about a space object. It's about awakening our curiosity and our responsibility to the unknown. Discovery of a strange traveler. A faint spark against the backdrop of endless darkness, 3I/Atlas drifted silently through the solar system's outskirts. Unlike most comets or asteroids, it displayed an unusual trajectory, an irregular, hyperbolic path that hinted at an origin beyond the gravitational influence of our sun. When astronomers first noticed this faint, moving object with telescopes trained on distant space, it initially appeared as just another icy body, tiny and unremarkable, barely distinguishable among countless others. Yet, what set 3I/Atlas apart was its trajectory, an indication that it was not gravitationally bound to our sun, but rather a wandering interstellar visitor that had journeyed through the dark voids between stars. As the observations intensified, the true nature of 3I/Atlas became clearer. Its surface was a dark, uneven landscape tinged with organic compounds, a mosaic of carbon-rich materials that shimmered subtly under the weak sunlight it reflected. The angular shape and irregular surface hinted at a tumultuous history, perhaps shaped by collisions or the intense gravitational tug of distant stars long gone. The object's low albedo suggested a surface coated with complex organic molecules, possibly including tholins, substances that, on Earth, produce a faint, reddish hue. Scientists speculated this environment could harbor a sort of molecular primordial soup, echoing the earliest stages of chemical complexity that might lead to biological processes elsewhere. Imagining the biological potential of such an alien body stirs both curiosity and ethical tension. If 3I/Atlas carried any form of life, or even just the molecular precursors, it raises questions about contamination and the risks of exposing our own planetary biosphere. Would even the tiniest microorganisms survive the environment of interstellar space? Perhaps not, given the harsh vacuum, cosmic radiation, and extreme cold. Yet, some argue that if life could endure such extremes, an environment of cosmic rays, vacuum, and freezing temperatures, then cosmic exchange might be more common than previously thought, fueling debates about planetary protection and our approach to future interstellar missions. This strange traveler could be a messenger, carrying clues about the cosmic chemistry that seeds life, or it could be a biological relic itself, a stranded package from distant stars. The journey of 3I/Atlas also underscores a mixture of wonder and caution. It reminds us how much remains unknown about the universe outside our solar system. Each new observation of this interstellar visitor intensifies ethical questions about how to study such objects without disturbing or destroying potential biosignatures. We are at the dawn of understanding, and perhaps responsibly, we need to think carefully about how we handle these celestial visitors, considering both scientific discovery and the preservation of unknown worlds. The silent, icy body continues its slow voyage outward, a cryptic reminder that our solar system is merely a tiny bubble in a vast, star-studded universe teeming with mysteries waiting to be unraveled. Unveiling the cosmic enigma. The discovery of 3I/Atlas, a comet originating from the far reaches beyond our solar system, shattered many preconceived notions about the boundary of our cosmic neighborhood. Its hyperbolic trajectory indicated it was an interstellar traveler, cruising through the solar system at a staggering velocity. Unlike long-period comets that originate from the distant Oort cloud, 3I/Atlas had an origin that defied the traditional boundaries we associate with cometary bodies, hinting at an extragalactic origin. Its surface glistened with a faint sheen of dust and ice, but glimpses of unusual mineral compositions suggested a history unlike those formed solely within our sun's realm. Its coma, a hazy halo shrouding the nucleus, shimmered with unpredictable bursts of activity, hinting at dynamic processes that might be remnants of alien environments. The journey of 3I/Atlas offers a glimpse into the bizarre encounters that come with interstellar objects brushing past our planetary neighborhood. Its arrival was marked by an intense sense of wonder and a touch of dread, highlighting our vulnerability and curiosity about what lurks beyond the known. Scientists observed that the comet's speed and direction made it clear it had not been gravitationally bound to our sun before this passage. Its path suggested that it had traversed vast interstellar voids, enduring cosmic radiation and dust clouds, perhaps for millions of years. As it traveled, the body's surface exhibited signs of erosion caused by high-velocity impacts with interstellar particles, giving it a battered yet resilient appearance. This physical resilience raises intriguing questions about the potential for life forms or materials that could withstand such extreme conditions. In contemplating the implications of 3I/Atlas, ethical concerns about our voyeuristic gaze into distant worlds emerge. Do we have the right to study an object that might harbor origins or histories alien to us? If any form of biological material managed to survive its epic voyage, the possibility of discovering extraterrestrial organisms, however primitive, would challenge everything we previously believed about life's rarity. The risks associated with sample return missions grow even more daunting, requiring meticulous containment and international cooperation. The comet's journey also prompts us to reconsider how we treat the small, seemingly insignificant bodies that drift through space. They might serve as messengers or carriers of secrets from distant galaxies, their silent travels reminding us of the vast, interconnected web of cosmic history that we are only beginning to understand. Charting the interstellar path. The voyage of 3I/Atlas is emblematic of humanity's expanding reach into the unknown corridors beyond our solar neighborhood. Unlike typical comets or asteroids that linger within the confines of our star system, 3I/Atlas was identified through a breakthrough in astronomical surveys that scanning capabilities became more sensitive, revealing a faint, fast-moving speck of light hurtling at a velocity that defied natural orbital patterns within our solar system. The initial detection was a jarring reminder that some objects are travelers, not residents, of the familiar cosmic neighborhood. Its trajectory suggested an interstellar origin, an alien visitor charting an uncharted course through the vast dark between stars with no ties to the sun's gravity well. Mapping its journey has involved an intricate dance of calculations that blend astrophysics with advanced computational modeling. As 3I/Atlas streaked past distant stars at hundreds of thousands of miles per hour, astronomers tracked its path using a multitude of ground-based telescopes and space observatories. The dust and cosmic rays that pepper interstellar space slowly carved impressions into its surface, altering its physical appearance in subtle ways that hint at its age and history, evidence of a long voyage through interstellar clouds and obscure star-forming regions. This continuous tracking helps scientists reconstruct a provenance, an intergalactic family tree that connects it to distant star systems, perhaps even to a specific planetary body or debris field. Every pixel of data collected, from its diminutive size to its reflectivity, adds to the puzzle of its origins. In charting this remarkable voyage, researchers grapple with ethical ramifications as well. The potential for encountering material not forged within our solar system raises questions about contamination and planetary protection. If 3I/Atlas harbors organic compounds or even microbial life, understanding how to handle such material demands caution and responsibility. The possibility that life forms or biological precursors might be fragile and uniquely adapted to their native environment compels us to rethink our stewardship of the cosmos. These interstellar visitors, while awe-inspiring, serve as a mirror reflecting our own curiosity and the moral obligations that come with exploring worlds beyond our direct reach. Observers are also increasingly aware that objects like 3I/Atlas challenge our notions of what it means to navigate the universe. Its course was not charted on a conventional solar map, but through a web of gravitational interactions with unseen stars, dark matter, and interstellar gas. While current models calculate trajectories based on the physics of motion and light, many questions remain about the subtle forces acting on such objects during their long journeys, from the drag of cosmic dust to magnetic field influences. Each element reveals a universe that is both more complex and more interconnected than previously imagined, reminding us that interstellar pathways are seldom straight, but woven through a tapestry of cosmic phenomena. As technology advances, our ability to forecast, intercept, and perhaps even communicate with these interstellar icons will grow, transforming the way we perceive and navigate these natural interstellar couriers. Decoding the alien signatures. The signatures observed in 3I/Atlas's trail defy familiar patterns, hinting at origins beyond our solar system. Among the most compelling clues are anomalous spectral emissions that don't match any natural planetary or asteroid signatures charted within our scientific databases. Instead, these emissions bear the hallmarks of a composition that suggests highly specialized technological activity. For example, faint but persistent infrared signals indicate some form of energy manipulation, possibly deliberate, emanating from the object. Researchers are captivated by the idea that these could be residual indicators of an alien craft's propulsion system, perhaps utilizing an exotic form of radiative thrust not bound by our current physics. Pinpointing the nature of these signals demands a nuanced understanding of their biological and technological implications. The emitted spectral lines, for instance, are not simply random noise but demonstrate a pattern that could mirror biological processes, something akin to passive bioluminescence or even some form of energy exchange associated with sentient life. If extraterrestrial organisms had evolved to use intense, directed energy emissions for communication, similar to how terrestrial species have harnessed light for signaling, then these signals could be a form of interstellar language encoded with meaning. Decoding them involves not only parsing their frequency and phase, but also contemplating their context within an alien ecology that may resemble or vastly differ from Earth's. Considering the environment from which these signatures originate provokes questions about the biology and adaptive capacities of any alien life forms responsible. Would they possess sensory organs specifically tuned to detect or emit these signals? Perhaps their biology has incorporated elements that make such energy emissions a natural byproduct or an intentional act of communication. These beings might have developed biological insulation against intense radiation, or even biooptical structures that amplify or modulate emissions, similar in some ways to bioluminescent organisms on Earth, but on a scale and complexity far beyond human understanding. This line of thought bridges technology and biology, reinforcing the notion that deciphering alien signatures involves understanding their possible biological rationale. Ethically, some scientists warn of the ramifications of assuming that these signals indicate a peaceful intention. What if they're a form of territorial marking or a warning? The act of decoding such signatures isn't purely a scientific task, it also involves responsibility. We must consider how interpreting alien signals could influence our perception of the universe and our place within it. Are we prepared to respond? And if so, how? The faint, enigmatic signals from 3I/Atlas challenge us not just to analyze the physical data, but also to reflect on the moral dimensions of making contact or revealing our own presence. As we piece together these cosmic hallmarks, the core issue threads through our actions. Understanding that alien signatures might be something more than just data, they could be profound expressions of life that demand both scientific curiosity and deep respect. Implications for humanity's place in the galaxy. The discovery of interstellar objects like 3I/Atlas fundamentally alters our understanding of our place within the cosmos. As this object plowed through the solar system at a remarkable speed, it carried with it the silent, cosmic stories of distant star systems, possibly bearing materials and signatures untouched by our local stellar neighborhood. The idea that such travelers originate from outside the sun's gravitational embrace hints at a universe teeming with debris, each fragment whispering of worlds formed in alien environments. This realization expands the scope of our cosmic neighborhood, no longer confined to the tentative boundaries of the solar system, but intertwined with the vast, dynamic tapestry of the galaxy itself. With the recognition that objects like 3I/Atlas are not rare anomalies, but part of a larger interstellar inventory, humanity must confront profound questions about biological and technological resilience. Could microbes or dormant life forms, if carried along in organic materials or planetary debris, survive the brutal vacuum and radiation en route here? Some scientists speculate that extremophiles, organisms thriving under harsh earthbound conditions, might endure interstellar journeys, huddled within rock or ice, patiently waiting for a suitable niche to reanimate. This possibility provokes ethical dilemmas about contamination, both accidental and deliberate, raising concerns about introducing Earth life to pristine extraterrestrial environments, or vice versa. Our approach must balance curiosity with caution, recognizing that crossing planetary boundaries might inadvertently seed ecosystems with unknown consequences. Considering our technological evolution, the very existence of interstellar visitors encourages reevaluation of our ambitions for space exploration. Propelled by the sheer speed at which objects like 3I/Atlas traverse the vast distance between stars, our current propulsion methods seem almost primitive. The potential to develop faster, more efficient means of interstellar travel might not only revolutionize space science, but also redefine humanity's relationship to the galaxy. We begin to see ourselves as participants within a broader cosmic network, with our technological footprint poised to expand beyond the bounds of the solar system. The implications challenge us to think ethically about how we approach alien worlds, whether as explorers, custodians, or potential hosts for passing cosmic visitors. Lastly, pondering humanity's place in the galaxy, spurred by the sight of objects like 3I/Atlas, triggers a profound sense of humility and wonder. Our planet, with its delicate biosphere, suddenly feels even more unique amid the endless stellar sea. If fragments from distant systems can journey across light years of space, it suggests that the universe is more interconnected than we often consider. Yet, it also reminds us of our responsibility to preserve this fragile oasis, recognizing that our actions ripple outward into an incomprehensibly vast cosmos. The arrival of interstellar visitors prompts us to reckon with our potential to make meaningful, respectful contact with the wider universe, inviting reflection on not just discovery, but stewardship of what we might find beyond our starry horizon. Preparing for future interstellar encounters. As the trajectory of 3I/Atlas shifts away from the solar system's familiar confines, scientists and explorers alike are pondering what it means to prepare for encounters with objects traveling from interstellar space. Unlike objects caught in the sun's gravitational embrace, these visitors come from environments vastly different, cold, sparse, where particle densities are minuscule and radiation patterns are unrecognizable. Yet, their approach prompts us to develop highly sensitive detection systems capable of discerning faint, high-velocity signatures amidst the cosmic cacophony. Advanced telescopes equipped with spectrometers analyze light curves and subtle wobbling motions, sensing minute gravitational pulls that could indicate a foreign asteroid or comet. This ongoing tuning of instruments aims to bridge the gap between what is currently detectable and the whisper-thin traces these objects leave in our observation fields. Biological adaptation plays an intriguing role. While most interstellar objects are rocky or metallic, discussions about potential organic or microbial remnants hitching a ride are speculative yet tantalizing. If such biological materials existed within a foreign asteroid, their exposure to extreme conditions, vacuum, cosmic radiation, temperature fluctuations, would demand extraordinary resilience. Preparing for this possibility involves improving our understanding of extremophiles on Earth and how they might survive interstellar journeys. Some microbial life forms on Earth thrive in conditions that mimic space, rock pores, high radiation, desiccation, fueling debates about panspermia. Developing sensitive bioanalytical tools that could detect signs of life or prebiotic chemistry on these objects requires a nuanced approach, merging astrobiology with astrochemistry. Ethics emerge as central to these preparations. Launching intercept missions or sample return endeavors must be balanced against safeguarding potential extraterrestrial ecosystems from contamination, an issue that becomes even more urgent if some interstellar objects carry organic compounds or microbial life. Containment protocols and sterilization procedures become critical. Otherwise, we risk corrupting untouched environments or introducing our earthly microbes into alien worlds. It is an ethical tightrope walk, the desire to learn and explore versus preserving the integrity of whatever worlds or life forms might be out there. As our technology advances, so too does our responsibility to approach these encounters with humility and caution, recognizing that even in our quest for knowledge, we hold the power to influence futures far beyond our own. Ultimately, preparing for future interstellar encounters involves an intricate web of technical innovation, biological insight, and moral reflection. Each discovery shapes our approach, forcing us to stay adaptable and vigilant. Interstellar visitors like 3IATLAS remind us that space is a vast, dynamic theater where new actors may arrive unexpectedly. Being ready means cultivating a global scientific community capable of rapid response, precise analysis, and deep ethical considerations. It is a challenge that underscores both our curiosity and our responsibility, facing the unknown with both wonder and prudence, eager to learn, careful to respect worlds beyond our own. Following its trajectory through the icy void, 3I/Atlas offers an extraordinary glimpse into the complexity of interstellar objects. Unlike typical comets or asteroids that originate within our solar system, Atlas's peculiar composition and trajectory suggest an origin far beyond the bounds of our cosmic neighborhood. As it hurtles through space, its surface reveals a patchwork of mineral-rich dark patches interspersed with icy grains, hinting at a history shaped by harsh, unrelenting space weather. Observers speculate that this object may have formed around a distant star system, subject to the kind of cosmic forces that forge complex organic molecules, potential hints at the building blocks of life elsewhere. The journey of 3I/Atlas is not just about traversing distance. It's about the potential for adaptation in environments wholly unlike those on Earth. If a biological entity or precursor arrived via such an object, it would need resilience to extremes. Imagine organisms that might survive in tiny, cramped niches beneath rocky surfaces, enduring radiation doses lethal to most known life forms and temperature swings that can fluctuate hundreds of degrees. While alien life may seem an improbable notion, the possibility exists that some form of hardy microbial life, possibly encased in protective biofilms, could exist on or within objects like Atlas. These microbes could adapt to the rapid transition from deep space to the warmth of a planetary surface, with dormant spores awakening under the right conditions, their biological chemistry subtly tuned to withstand cosmic stressors. From an ethical perspective, the investigation into such objects raises profound questions. Sending probes or collecting samples could introduce Earth-based microbes to extraterrestrial environments, risking uncontrollable contamination. Conversely, missing the opportunity to study objects like Atlas overlooks elements of cosmic history that could reshape humanity's understanding of life's potential beyond Earth. There's a tangible tension between curiosity-driven exploration and planetary protection protocols, demanding careful, deliberate strategies. This also prompts reflection on our role as stewards of not just terrestrial life, but of the broader cosmic environment, potentially influencing phenomena we can scarcely comprehend at present. Ultimately, 3I/Atlas embodies the fragile border between discovery and mystery. Its passage ignites curiosity about the origins of complex molecules and the universality of biological resilience. Each observation stirs a sense of wonder, as scientists piece together clues from spectral signatures and surface features that hint at a long journey across cosmic expanses. As we decode its composition and trajectory, we not only gain insight into a phenomenon that defies easy classification but also confront essential questions about our place in a universe filled with objects that have traveled through the cold, silent vastness for eons, objects that may someday tell us stories we've yet to imagine. As we reflect on the remarkable journey of 3I/Atlas, it's incredible to realize how this tiny traveler has challenged our understanding of the cosmos. From its origins beyond our solar system to the tantalizing glimpses of its surface, we've glimpsed a world shaped by processes neither entirely familiar nor completely alien. Its swift passage through our neighborhood reminds us that the universe is teeming with objects that evolve and adapt in ways we're just beginning to comprehend, a testament to the resilience of cosmic bodies that, much like life on Earth, find ways to survive and thrive under conditions both harsh and unknown. Imagine future missions that could analyze its composition more deeply or even trace back its journey through stellar nurseries, revealing secrets about the ancient stars that birthed it. The ethical questions surrounding planetary protection and our right to explore such celestial visitors deepen our connection to this ongoing story. Are we stewards of the universe or merely curious spectators? First, hope these discoveries spark your wonder and curiosity, because, trust me, we're only scratching the surface. There's so much more to learn, and every new piece of data invites us to think bigger, dream bolder, and explore further. Stay tuned for upcoming explorations. Who knows what other cosmic mysteries are waiting just beyond our reach? The universe isn't done revealing its secrets anytime soon.